Hello everyone. The next type of problems is on the frames. So you can see here, this is a frame wherein at end A and D there are supports. So end A has a hinge support, end D has a roller support. Okay, so hinge support has two reactions. So I've shown the reactions, and D at end D there is a roller support, so one reaction. So in the problem they've asked you to determine the horizontal displacement of the roller support end D of a frame shown by in the given figure by Castigliano's theorem. So take EI is equal to constant. Okay, so EI is constant here. So it is a frame wherein A, B, C, and D are the members of the frame, and at D there is only one load acting. It is a horizontal load 5 kilonewton. So for this you have to find the horizontal deflection at A. There's external load at D. Find the horizontal deflection at A. This is what they asked to find. Okay, so as usual, first to find the horizontal deflection A, so only take the horizontal forces. So the horizontal forces here are RAH, right side, so positive, minus 5 kilonewton acting to the left is equal to 0. So RAH is equal to 5 kilonewton. Okay, so they have asked to find only horizontal, so we'll consider only the horizontal forces. Okay, then next, to calculate the moment at different ends. So you have to cut all the three sections, that is A, B, B, C, and C, D. You have to cut all the sections and you have to find the moments. Okay, so first portion AB. AB is first portion, BC second portion, CD third portion. So we'll always start this in a clockwise direction. We'll always use this clockwise. So AB, BC, and CD. So origin first, because end A is hinged. So origin for A, if I cut the section here, there is load here. So end in AB portion, end A is the origin, BC, B. Then in CD, because there's a load here, it is easy to find force into perpendicular distance. So I'll take this D as the origin. Next, limits are same, 0 to L, 0 to L, 0 to L. So because there are three different portions, so we'll start the 0 to L, then from here 0 to L, from here 0 to L. Next, we'll find the moments. So what I'll do, the first thing in AB portion, I'll cut this section like this. So in AB, there are two forces. When I cut the section at a distance x from end A, so RAH, okay, RAH, which I already found out here, that is 5 kilonewton. Now this 5 kilonewton, I'll take it as P. Okay, so RAH is 5 kilonewton, I all know. The external load will be replaced with letter P. So RAH 5 kilonewton, I'll write it here. P, I'll write it here, C. P is 5 kilonewton. Okay, so now in this section, if I cut this section, so because both are equal and opposite, so RAH is going anti-clockwise. So anti-clockwise, RAH is equal to 5, which is nothing but P. So it is minus P into perpendicular distance x. Similarly, in BC portion, I'll cut this section here. In BC portion, so origin is B. Okay, so again, this 5 kilonewton, okay, into its perpendicular distance. So this is RAHP. So P into perpendicular distance to reach B is L. Though you're cutting the section here and writing it X here, but with respect to the load, the perpendicular distance is L. So it is minus P into L. Then in the third section, so that is this portion. Okay, if I cut the section here, okay, I've cut the section here. Again, in this section, this P is going anti-clockwise. So minus P into perpendicular distance X. Okay, so once I find out this, next EI is constant throughout. So EI, EI, and EI. Then dou M by dou P is equal to, so dou P by dou P cancels, so it is minus X. Here also dou P by dou P will cancel, so we're left with minus L. Again here it has P in it, so dou P by dou P will cancel, there is only minus X. Now take these two values and multiply, put it in the formula. So delta D, delta means deflection at D, which is horizontal. So that's why it's called as delta D. H indicates horizontal, is equal to 0 to L, 0 to L integration of m over ei into dou m by dou p, m over ei dou m by dou p into dx. Again, next second quantity, again 0 to L m over ei dou m by dou p into dx, 0 to L m over ei dou m by dou p into dx. So for all three portions, so now we'll choose. So 1 over ei, I'll take it common. M is first p minus p into x into minus x into dx. Similarly, next minus p into L into minus L. Third, minus p into x into minus x. So again, take p common outside for all three. So limit would be same, x square here, L square here, x square. So again, solve this. So x cubed by 3 here, it is only L with respect to dx, which is L square into x. And here it is again same, x cubed by 3. Then solve this. So once you solve this, you will get the answer here. So that is 1.67 PLQ by EI. But now that you already know the value of P, so P is 5 kilonewton. Because it is 5 kilonewton, it is 5 kilonewton. So substitute here 5 kilonewton and solve this. So delta DH is 8.35, 8.350 over EI. Okay. Now, so they've asked you to calculate only the horizontal deflection at A. So you've replaced this external load with P and found out the horizontal deflection at D. Okay, the next problem is find vertical and horizontal displacement at free end D by Castigliano's theorem. Find vertical and horizontal deflection at D. So this is the point D. So in D, you have to find both horizontal and vertical displacement by Castigliano's theorem. Okay, so first find the vertical deflection. So let us find the vertical deflection at D. Now to find vertical deflection at D, see at D there is no load, absolutely no load acting. So what we'll do, because we want to find vertical deflection, I'll apply vertical load, dummy load P in this direction like this. Apply vertical dummy load at P. So this would be 0. Alright. So first let us find the vertical deflection. Now to find the vertical deflection, okay, because there is a hinge support here, I'll take the horizontal forces. Here there is 100 kilonewton acting to the right side. Okay, so first I'll find RAH. To find this RAH, so I know that RAH is acting to the right, and there is 100 kilonewton also acting to the right. So only two horizontal forces. So because there are only two horizontal forces, so RAH plus 100 is equal to 0. So RAH is minus 100. So now RAH is acting like this, left side. So the answer is minus, so it is acting left side. Okay, now let us calculate the moment. So I'll cut the sections A, B, B, C and C, D. Okay, now see here, as usual, first I'll consider this AB as one portion, BC is another portion, CD is another portion. Origin. Now, if I cut this section here, AB, okay, in AB, if I cut this section here, because there's a UDL acting here, so what I'll do, I'll take the right side end. So if I cut the section, either say I can see to the left or I can see to the right. But now my concern is I will see to the right side of the section. The reason why is because there's a UDL in it and there's 100 kilonewton force. Okay, so origin for AB is now B, for BC it is C, and for CD it is D. Okay, so our limits are 0 to 4, 0 to 4, 0 to 2. Okay, so next let us find the moments. Now to find the moments, we'll always start like this. So I've cut the section AB. In AB, I've cut this section. Then from here I'll start. P, it's going clockwise. So P into 4 is one force. P into 4. Next, one load is over. Next, 100 into X. That is also going clockwise. So plus 100 into X. Next, plus 60 into 4 into 4 by 2. 60 into 4 into 4 by 2. Okay. That is it. Then solve this 4p 480 plus 100x. Next, similarly go for section BC. So in section BC, I'll cut the section here. Okay, I'll again see to the right side of the section. To the right side of the section, again there is p into x. Next, 60 into x by 2. P into x, 60 into x into x by 2. Solve this, then it is px plus 30x squared. Okay, next, in section CD. So if I cut the section, it is like this. X is this distance. X is also vertical, P is also vertical. So there is no perpendicular distance. So moment in this portion is 0. Okay. So EI is constant throughout, so I'll let it same. Next, differentiate this with respect to P. So 4P, in this equation, there is only 4P. So P is only in this part. So it is 4. Next, in next part, okay, in this BC portion, there is only Px. So only this value should take. So dou P will cancel, only x remains. So here it is 0, so 0. Okay, so now apply the Castigliano's theorem. So again, when you apply Castigliano's theorem, so it is delta dV. So you're finding deflection which is vertical at point D. So 0 to, the first one, 0 to 4. 0 to 4. So m into dou m by dou p. M into dou m by dou p. Again same, next 0 to 4. M into dou m by dou p, and next no need to write because it is 0. Okay, so I'll just write 0. Okay, now we know that P is a dummy load at vertical point D. So put P is equal to 0. So 1 over EI, 0 to 4, multiply this value with respect to 4. So when you multiply, you get this answer. Similarly, multiply this here. So you'll get this answer. As it is P is 0. Okay, so only consider the numbers here. Okay, so solve this. Once you solve this, integrate, substitute the values. So we'll get delta dV is equal to 12800 over EI. They have not given the value of EI, so keep it as it is. Similarly, calculate the horizontal. To find the horizontal deflection at DT. So to find horizontal deflection at D, apply a horizontal dummy load. Again, at D there is no load, absolutely no load. So apply a horizontal dummy load at D, that is P, which is acting to the left side. Okay, so we know that R 100 kilonewton is acting to the right side and P is acting to the left side, and RAH, which we have already found out here, RAH is acting to the left side. Okay, so now we know that HA is equal to minus 100 minus P. Okay, we are more interested in this value P. Okay, so now let us calculate the moment. So portion, again as usual, portion AB, BC, CD remain same. Next, again the points, origin B, C and D remain same. Then limits 0 to 4, 0 to 4, 0 to 2. Okay, the only thing changes here is the moment. Okay, first I've cut this section here. So P, again I'll see to the right side because P is lying on the right side of the section of AB. So it is P, okay, P into this distance. So this is total is 2. From 2 you have to deduct x because x is greater, 2 is smaller. Okay, so P into 2 minus x. Okay, 2 minus x. Next, it's going clockwise, so plus. Next, in this is over. Next, 60 into perpendicular distance. So 60 into 4 into 4 by 2. Next, 100 into x. 100 into x. Okay. Similarly, next, I cut this section here. P into perpendicular distance. P perpendicular distance is 2. So P into 2. Next, 60 into x by 2. Okay, that's it. So you're seeing only to the right side of the section. Next, in CD, Again, this is P into X, positive. Okay, so EI is constant throughout. So this has only P in it. So whatever, dou P cancels, so it is 2 minus X. Again, this has only P in it, so it is only 2. And again, this has P in it, so it is only X. Okay, so apply the Castigliano's theorem and find out. So delta DH, it is deflection at D, which is horizontal, is equal to 0 to 4 first, 0 to 4, 0 to 4, 0 to 2, 0 to 4, 0 to 4, 0 to 2. Again, as usual, put this as M. So this is M into dou M by dou P plus, again next M into dou M by dou P, this M into dou M by dou P. So when you go on integrating and solving it, put P is equal to 0. So once you put P is equal to 0, things become simple. Okay, 0 into anything, this portion is 0. Only you have to solve for this. Multiply this into this. And then once you go on solving this, so you'll get the answer as 746.67. Okay. Again, there is no EI value given. So 746.67 divided by EI. Okay. The next one is last type of problem is determine the horizontal deflection at D for the frame. Assume E is equal to, okay, they've given you two E values. So now here E is in Newton and mm square. So you have to convert this into kilonewton and meter square, because the original load what is given here is in kilonewton and meter square. Okay, so first we'll take this EI value. So first convert EI, write the value. It is in Newton, convert it to kilonewton. So 10 to the power minus 3. Okay, divided by mm square. So mm 2 meter, 10 to the power minus 3 square into next I value. 8 into 10 to the power 8 into, again, mm 2 meter is 10 to the power minus 3 is to 4. So EI is equal to this value. Okay, so they have asked us to find only the horizontal deflection at D. Okay, so to find horizontal deflection at D, again at D there is a vertical load acting, vertical load, but there is no horizontal force acting. So because there is no horizontal force acting, apply a dummy load at D, which is nothing but P. So then calculate the moment. So calculate the moment about X. So again, apply the table, use the table and find portion AB, BC, CD. So origin for AB is B, BC is C, CD is D. Okay, limits 0 to 3, 0 to 3, 0 to 4. Okay, now moments. So moments, I've cut this section here. In AB portion, I've cut the section here. So now it is to the right side of AB, there are only two loads acting. One is 40, the other is P. So it is 40, it's going clockwise. So 40 into perpendicular distance 4. Okay, next P, again it's going clockwise. It is P into this distance. So P into perpendicular distance to reach this point. So it is P x plus 3. So next, after this, there is also a load here. It is 20 into x, only this distance. So it is again clockwise 20 into x. Solve this and keep it. Next, similarly in BC portion to the right side, there are only two loads. So it is 40 into 4 is P into x. I'm putting the section here. So P into x. Next, in the last portion, we cut the section here. So it is P, perpendicular distance, not that. Perpendicular distance, that is x and P are in the same line, they're parallel to each other. So now it is 40 into x only. Okay, so EI is constant throughout. So dou M by dou P is only this value has P in it. So rest all becomes 0, only this has P in it. So it becomes x plus 3. So dou P will cancel, is x plus 3. Next here it is 160 plus px. So only this has px in it. So dou P will cancel, only x. And here there is no p value. So this term becomes 0. Okay, once you find out this, next is mx into dou m by dou p. Go on multiplying. Okay, so dh, delta dh, horizontal displacement is 1 over ei. I'll take it common. So first is 0 to 3, this value into this. Written this 160 into this one into this, plus 0 to 3, 160 plus px into x. And the last one is 40 into 0, so it is 0 only, so no need to write this. Now let us put the value of p, that is p is equal to 0. It's a dummy load, put p is equal to 0. So if you put here p is equal to 0, things becomes easy to calculate. So this term gets goes, this is out. So it is 160x, 160 into x. Okay, first here. Multiply these two. So 160 into x, then 20 x square 480. So go on multiplying these two brackets, then these two brackets, and finally go on solving this. The last term is 0. So once you solve this, substitute the values from 0 to 3. Okay, so you'll get this as 3330.09 over EI. Now that you have the value of EI here, it is 116 to 10 to the power 3. Substitute here, and then you'll get the horizontal deflection at D. Okay, so the only thing about frames is if there is no loads acting at the given point, whether it is horizontal or vertical, then you have to apply a dummy horizontal or vertical load at that given point and solve this in the form of table. Okay, that's it for today. Thank you.